Welcome. So this is a projectile motion problem, and a cannonball has been fired on level ground. So let's draw this. A cannonball has been fired on level ground. It's been fired at a muzzle speed of 40 meters per second. So this is 40 meters per second at 30 degrees above the horizontal. So that's 30 degrees. What's going to happen is the cannonball is going to go up and it's going to hit the ground somewhere. And the question is, what is the maximum height above the field? So we're actually trying to find this height here. And that's a vertical piece of information. So let's just imagine looking at the vertical component of the behavior. So the object starts here, and vertically it goes up to this point here, and then it comes back down again. And because we're interested in the maximum height, we'll say vertically the journey, the part of the journey that we're interested in ends there. So what we have to do is find, let's say it's delta x, the displacement vertically. And then what I'll do is I'll determine the height based on my answer using, and I say delta x because it's displacement. You could say delta y if you want. The key thing is this is vertical stuff. So I'm going to say using vert info. So I use delta x to mean displacement no matter which direction it's in. So delta xv is the vertical displacement. On my diagram, that is delta xv. Okay, so what do I know vertically? Well, I know that my vertical component of velocity is not 40. 40 is the line along the hypotenuse. I want, let me find my pen, I want this component. And hopefully with practice of components, you're comfortable saying, oh yeah, VI vertically is equal to 40 sine 30. And with your calculator, you can figure out that that's going to be 20. And it's going upwards, so it's positive 20 meters per second. So I recognize that my muzzle velocity is important, but it's not the velocity in the direction that I'm doing my problem. I'm doing my problem vertically, so I have to find the vertical component of the muzzle velocity, which is 40 sine 30. And then I know my acceleration is equal to minus 10 meters per second squared. I need another thing, and conceptually I recognize that my vertical velocity at the top of the journey equals 0. It stops going up before it starts falling down. So that is 0 meters per second. And that's a conceptual understanding. And then I want to find my displacement. So if I look at this, I can try and figure out what links them. And I can say, yeah, VF squared equals VI squared plus 2a delta x. My final velocity is 0, so vertically. So I have 0 squared, and this equals plus 20 squared plus 2 times minus 10 times delta x. So delta x is going to equal, well, Well, delta x is going to equal 20 squared over, minus 20 squared over minus 2, let me, over, and now we're dividing 2 times minus 10, which equals minus 400 over minus 20. Delta x is equal to plus 20 meters. That means my displacement is a positive value and it's 20 meters long, which means my height, h, is equal to 20 meters. Height is a scalar, it's equal to 20 meters. Answers there. So there we have it.